Hello. Today is Thursday, December 3rd, 2020. My name is Daniel Mullany, and behind the camera today is Caitlin Yates. We are filming a video source inspection of a fully refurbished mask cleaner. This system will be shipping to the East Coast, and our customer's PO number is 40249. Throughout this video, I apologize if the audio cuts out at all. We'll be adding subtitles to the video as needed. We have another mic coming, but this one's a little shorted sometimes as I'm filming, so just bear with us on that a little bit. Here we have a fully refurbished K&S 971 mask cleaning system. This tool is configured with a standard mask cleaning process, which will have high pressure DI water that has been reionized by carbon dioxide gas. It has a rotating chuck capable of washing multiple different substrate sizes. It has a nitrogen blow-off feature and a heat lamp. So really it performs the standard mask cleaning process, which is using high pressure DI or reionized water to physically knock particles and any other resist residue that would be on a mask from its operation in a liner within the fab. So what I'm going to do first is, it might be a little difficult from the camera to see, but and it's a little awkward for me to keep this mic on, but I'm going to try to get down like here. Okay, so I'm taking a look underneath. Here we have some gauges for the nitrogen drying, the PSI set point for the high pressure pump. We have various other switches to ensure that when the system's running, that the interlocks are met. There is a reionizer in the back, which is where the DI water mixes with CO2 in order to reionize the water for the standard operating process. And everything's clean here. All the wiring is tidied up, and the system looks nice and neat underneath here in its original configuration after our refurbishment. Okay. All right. So now we're going to take a look at our system here. So what I'll do is first I'll run down what we have over here in a really easy to use and typical set of controls. We have our nitrogen dry PSI set point. We have our CO2 reionizer set point. We have a tachometer which shows the RPM of the chuck during operation. Here you can set the wash RPM and the wash time. Here you can set the dry time and the dry RPM. Here is where we can purge the pump to be done before operation. We have an emergency off and a cycle start. So everything here is pretty self-explanatory. The only one that I want to talk about here is the purge. This allows you to run the pump. What this is standard for many pumps is that you want to purge the line prior to operation. It's important that you purge the line with DI water in order to ensure that the line itself is primed. You don't have to do this before every run, but it's important to ensure as part of a daily startup that the pump's primed. In most cases, you're going to find that it maintains itself primed unless it sits for quite a while, but it's a good operating procedure just to, in the beginning of the day, ensure that we have it primed here. So what I'm going to do is I'm going to go and open the chamber. We'll take a look inside. So here we have our mask demonstration for today. This is a 7x7 mask. Here's the heat lamp I mentioned for drying. Here is the high pressure spray arm for the actual spraying and cleaning of the mask surface. Here's our N2 blow off. And then here we have our rotating chuck. On the chuck, you'll see we have these steps on either side. Please note that there's additional holes here, so you can move the steps from this position up to the closer position. That then gives you a different range of mask sizes to run. We have it currently configured to be running 6, 7, 8, and 9 by 9-inch masks. So that's a 7x7. The customer would like it configured for 5x5 and 7x7. So when we ship, we're actually going to adjust these back in. So this will be configured for 5x5 and a 7x7. Okay, but for now we can easily run that. So I've just installed the mask. And then what I'm going to do as well, Caitlin, if you won't mind showing this again one more time, I'm going to go ahead and purge the line so you can see what I'm referring to, as this is important for tool upkeep and maintenance. If you take a look down the line right here, so I just turned on line, which means press water through the line, or turn on the water facility. You can see it going on my finger right there. It's kind of splashing on the mask. That's important right there to ensure that it was primed. You may have noticed that right as I hit line, water started coming out. That's because we were already primed from running process cycles throughout the days leading up to this video. So we'll go ahead and turn that back off. Now, another important part about operation with this tool is that there's a air cylinder that assists with opening the door and then closing it. So when you close it, you're actually just going to close part way, and then it will bleed the line from that cylinder as it closes. If you push down, you're going to put stress on that cylinder, and it may not actually close all the way when you push it down. It may push down, but then the back's not closed because that cylinder hasn't bled. That will leave a gap here, and it'll give you errors throughout operation. So just make sure that when you're closing it, you just put it halfway and know that it's going to slowly close itself. We have a note here as well, but it's important just for startup and training that you follow that procedure. Okay, so we should be good to just go ahead and run the tool. Now, you may have noticed as well, one more thing I want to notice is that these gauges, this tool being a little older vintage, does not have necessarily the times or the speeds listed. So what you'll do is you'll set those speeds by doing demo runs. You'll look at the tachometer and you can adjust the speed during operation. It's okay to physically adjust speed that's slowed down. Once you've hit your set point, then your system's set. And then for time, you can actually use you have to use just like a timer to document the times that you want to run on this, and you can check up on that. But once the tool's set, you should really just have one recipe for regardless of the mask size. So we've already set this right now to a recipe that successfully runs this mask as well as the other masks we've run in here, and we're going to go ahead and press start. So this is where the fun begins. Okay, so right now the system is in operation. As I mentioned, it's a standard mask cleaning process. So what we have is we have an oscillating spray arm that is moving across a mask that is rotating at a slightly high RPM. We have it set for 600 right now. It's typical that the water will be spraying out maybe approximately 1500 psi. It's enough to potentially rip skin off your hand, which is how hard we want this. We want it to physically knock all particles and all resist off of the mask, while also not hard enough to actually damage the chromium or the mask itself. About 1500 psi is a standard for that, and will not cause any damage, and will get pretty successful results. But this is something that'll be part of your own process engineering with a system like this, is adjusting these times, RPMs, set points, and finding one that works well with your specific contamination issue, and usually resist type. How hardened it is, what it takes to remove it, how long that process looks like, how fast you want the chuck spinning, etc. So everything is looking good. The sweep of the arm has already been preset by us. It's an adjustment that can be done on the base of the arm inside the chassis of the tool. It determines how far and how fast the arm sweeps. We have it set to be sweeping just past the middle, then back out to the edge, past the middle, back out to the edge. That will then allow this system to work with any any mask size that you put in it, regardless of how you adjust our step chuck. So now we have moved into our dry cycle. So the dry cycle is pretty straightforward again. We're just going to continue spinning. Now we're ramped up to a higher RPM. Our set point on this is about 1600. Excuse me. And now the spray arm has ceased with its oscillation and its pumping. And now we just have the heat lamp and the N2 blow off. So really what we're doing is we're spinning fast enough to have the water droplets working their way off the edges while we're assisting with a direct N2 blow off, and then heating and warming the entire chamber for evaporation with a heat lamp. What will be important for installation as well is to ensure that you have your exhaust set up. We do not have exhaust in this area of our manufacturing floor, so we don't have the exhaust on at the moment. All that's really going to do is affect our dry times and the humidity of the chamber. But when installed in the fab, you'll want to have that exhaust on, so that way you're constantly pulling humidity from the chamber, you're improving your dry times, and you're going to just overall get better throughput and improved process results on the mask surface. Okay, now I'm just taking a look at these gauges. The CO2 reionizer is still sitting about 20 psi. That's going to maintain a pretty consistent pressure. And then the nitrogen dry is now up to 25 psi. In the beginning of the video, you'll notice that when idle, the nitrogen dry was at 0 psi. That's because this gauge reads what the actual output is. So what you can do is when after you hook up facilities, you can run the tool and then adjust the nitrogen flow rate and pressure from the gauge at inside the chassis of the tool here, and then make sure you get about a 25 psi set point during operation. That'll be an effective and correct drying procedure for you. All right, so now we have completed operation, but we still have our cycle start light on here. I can also see that we have our locking pin preventing from opening the chamber door. So the system is now finished operation, but the door is still locked, so we have to wait a minute here before opening. Okay. All right. So we've now completed our process cycle. We can take a look at the mask. So here we have our mask here. Everything looks good with it. This is just a used mask that we have on hand, so there's little damages on it. This is just for testing purposes. But the mask looks good and will be ready for putting back into storage and rotating back in through your lithography process. Okay, so as I mentioned, when you close the door there, you want to make sure it's not pushed down, let it bleed, and the door closes. Great, so I'd like to thank you for taking the time to view our video source inspection for today. Again, I filmed this video source inspection for SciTech Process Solutions. If you'd like to give us a call or visit our website for more information about this equipment or any others that we refurbish and provide to the semiconductor marketplace, please do so. Our website is www.scitechprocess.com. SciTech is spelled S-I-T-E-K, and you can give us a call at 916-797-9000, and to reach me directly, dial extension 2201. Thank you very much for your time, and have a great day.